Hello everyone, welcome to this lecture. I am Amlan Das. Today I will discuss about black hole. Okay. What is black hole? Black hole is a region of space which is so dense and it has a strong gravitational field in it that no particle, not even light or any kind of radiation can escape from it. Its escape velocity exceeds the speed of light. Okay. Now, black hole has a one-way surface called event horizon into which objects can fall but cannot come out. Black holes are predicted by Einstein's general theory of relativity, which shows that if a quantity of matter is compressed within a critical radius, no signal can ever escape from it. Okay. Now, depending on their physical masses, black holes are divided into four classes. Okay. First is supermassive black hole. Second is intermediate mass black hole. Third is stellar black hole. And fourth is micro black hole. Okay. Now, supermassive black hole has mass about 10 to the power 5 to 10 to the power 10 times the mass of the sun, and its radius, its size is about 0.001 to 4000 astronomical unit. Okay. Now, second is intermediate mass black hole. Intermediate mass black hole has mass about 10 to the power 3 times the mass of the sun, and its size is about 10 to the power 3 kilometer. Third is stellar black hole. Stellar black hole has mass about 10 times the mass of the sun, and its size is about 30 kilometer. And fourth is micro black hole. Micro black hole has mass about around the mass of the moon, and its size is up to 0.1 millimeter. Okay. So, these are the four types of black holes according to their physical masses. Okay. Now, according to their property, that is whether they are rotating or non-rotating, charged or non-charged, black holes are divided into another four classes. Okay. First is Schwarzschild black hole. Second is Kerr black hole. Third is Kerr-Newman black hole. And fourth is Reissner-Nordström black hole. Okay. Now, Schwarzschild black holes are non-rotating and they are not charged. Kerr black holes are rotating without charge. Third is Kerr-Newman black hole. Kerr-Newman black holes are rotating with charge. And fourth is Reissner-Nordström black hole. They are charged without rotation. Okay. So, these are the four types of black hole according to their property. Okay. That is whether they are charged or non-charged, or rotating or non-rotating. Okay. And these are the four types of black hole according to their physical masses. Okay. Now, rotating black holes obey exact black hole solution of Einstein's general theory of relativity. Now, as most star rotates, it is expected that most black holes in nature are rotating black holes. Okay. So these are the different types of black holes. Now we discuss about event horizon. Okay. Now we discuss about event horizon. The defining feature of a black hole is the appearance of an event horizon. Event horizon is a boundary in space-time through which matter and light can only pass inward toward the mass of the black hole. Nothing, not even light, can escape from inside the event horizon. Okay. Now, event horizon is referred to as such because if an event occurred within the boundary, information from that event cannot reach an outside observer, making it impossible to such an event occurs. Okay. Now, as predicted by general theory of relativity, the presence of mass deforms space-time in such a way that path taken by particle bend toward the mass. Okay. And at the event horizon, this deformation becomes so strong that there are more paths going towards the event horizon. Okay. Now, suppose this is a black hole. This is a black hole, and this is black hole, and this is the event horizon. This is event horizon. Okay. Now, here we draw space, and along this axis we draw time. Okay. So this is a black hole, and this is the event horizon of the black hole, and this is space-time curve. And far away from the black hole there is a particle. Okay. Far away from the black hole there is a particle. Now, far away from the black hole, a particle can move in any direction. Suppose this can move in this direction, this can move in this direction, in this direction, or in this direction, or in this direction, whatever its direction may be. Okay. So far away from the black hole, a particle can move in any direction, only restricted by the speed of light. Okay. Now again we draw a black hole. Okay. Again we draw a black hole, and this is the event horizon of the black hole. Okay. And here we draw space, and here we draw time. So this is the space-time curve. Okay. Now suppose closer to the black hole there is a particle. Okay. Now closer to the black hole, space-time starts to deform, and there are more paths leads towards the black hole. Okay. So path of the particle will be this type. Okay. All the paths are going towards the black hole. So closer to the black hole, all paths are going towards the black hole. And suppose we draw another type of another black hole. This is a black hole, and this is the event horizon of the black hole. Okay. And here we draw space, and here we draw time. Okay. This is a black hole and this is the event horizon of the black hole, and here we draw space time. Okay. Now inside the black hole, suppose there is a particle. Now inside the black hole, all the paths bring the particle at the center of the black hole. Okay, all the paths bring the particle at the center of the black hole, and there is no possibility for the particle to escape from the black hole. Okay, so inside the black hole there is no possibility for the particle to escape from the event horizon. Okay, so thus we discuss the event horizon. Okay, now we discuss about singularity. Okay, now we discuss about the singularity of black hole. Now according to general theory of relativity, at the center of the black hole lies a gravitational singularity where space-time curvature becomes infinity, and this singular region has zero volume, and this singular region contains all the mass of the black hole solution. Okay, thus the singular region can be thought of a point of infinite density. Okay, so this is the singularity of the black hole. Now we discuss the how black holes are formed. Okay, that is formation of the black hole. Okay, now we discuss formation of black hole. Primary formation process for black hole is gravitational collapse. Okay, primary formation process for black hole is gravitational collapse. Now gravitational collapse occurs when object's internal pressure is insufficient to resist object's own gravity. Okay, for star this usually occurs either because a star has too little fuel to maintain its temperature through stellar nucleosynthesis, or because a star that would have been stable receives extra mass in a way that does not raise its core temperature. Okay, now if the mass of the remnant exceeds 2 to 3 solar mass, if the mass of the remnant exceeds 2 to 3 solar mass, and it is also called Tolman-Oppenheimer-Volkoff limit. This is called Tolman-Oppenheimer-Volkoff limit. If the mass of the remnant exceeds Tolman-Oppenheimer-Volkoff limit, that is 2 to 3 solar mass, either the original star was very heavy or the remnant collected additional mass through the accretion of matter, even the degeneracy pressure of neutron is insufficient to stop the collapse. Okay, so this is the process through which black holes are formed. Okay, now another possibility for the formation of black hole is primordial black holes. Okay, so second process is primordial primordial black hole. Now, early in the universe, shortly after the Big Bang, densities were much greater, and it possibly allows for the black holes, and these black holes are called primordial black holes. Okay, but until now no such black holes are observed. Okay, so these are the formation process for the black hole. Also there are many other process of the black holes, whatever it may be, but we discuss only two possibilities for the formation of black hole. One possibility is possibility for the black hole is gravitational collapse, and second possibility is primordial black holes. Okay, and another possibility will be high energy collision. Okay, so these are the formation process for the black hole. That is how black holes are formed. Now we discuss about the growth of black hole. Okay, now we discuss about the growth of black hole. Once a black hole has formed, it can continue to grow by absorbing additional matter. Okay, any black hole continuously absorbs gas and dust from its direct surrounding and omnipresent cosmic background radiation. Okay, and this is the process through which a supermassive black hole has to grow. Okay, now another possibility is for black hole to merge with another object such as star or any other black holes. Okay, and in this process this black holes are grows. Okay, black hole grows. Thus we discuss the growth of the black hole, and at last we discuss the evaporation of the black hole. Okay, so we discuss evaporation of black hole. In 1974, the great scientist Stephen Hawking showed that black holes are not entirely black but emits a small amount of thermal radiation, and it's known as Hawking's radiation. Okay, by applying quantum field theory to a static black hole background, he showed that black hole should emit particle through a perfectly black body spectrum. Okay, through a perfectly black body spectrum. By applying quantum field theory to a static black hole background, Stephen Hawking showed that black holes should emit particles through a perfectly black body spectrum. Now, if Hawking's theory of black body radiation is correct, then black holes are expected to shrink and evaporate over time because they loses mass by the emission of photons and other particles. Okay, if Hawking's theory of black body radiation is correct, then black holes are expected to shrink over time by the emission of photons and other particles. Okay, thus we discuss what is black hole, what are the classifications of the black hole, okay, and how black holes are formed, growth of the black hole and evaporation of the black hole. Okay, thank you for watching this video.